Hey, happy Pi Day, everybody. Wanted to show you a Pi related project actually. This is what we call RATT. This is a system that Adam Schrei, Paul Hart, and I have been developing for Make It Labs. It is a tool control system, tool access control system. RATT stands for RFID, all the things. So every important tool that we have at Make It Labs is going to get this system on it. We already use these key fobs that are similar to what you might have it for work to get in to the building. We're going to be adding that kind of access control to all the expensive tools. So we've been developing this system. The reason this is a Pi Day related project is because this is based on a Raspberry Pi, which I'll show you in a minute. But the basic idea is you take your fob, you walk up to the tool, tag in, it does a check, and then activates the tool and allows you to use it. I don't have it connected to a real tool right now, but as you turn the tool on and off, you'll see that it goes active and shows how long you're using it. When you stop using the tool, when you turn its power off, it'll sit there and count down. Eventually it'll time out. It will warn you before that timeout comes up. We'll hit it here in a couple seconds, just so if you walked away from the tool and didn't log out, it beeps at you and says, hey, you're still logged in here. Say we're done with the tool, you can walk back over, log out. For safety reasons, we will be monitoring in most cases, the current draw of the tool. So if you tried to badge in and it detected that you had the power switch turned on, it'll complain at you and say, no, you can't do that, because we don't want the badge to turn the saw on, for example, because that would be dangerous. So the idea is that you have to badge in, it does a check, make sure the power switch isn't on, and then it lets you actually use the tool as you normally would. If it's a tag that it doesn't know about, it complains at you. If you are a person who does not have access to this tool, if you haven't been trained on it, that's all maintained in a database on the back end. It will tell you that, give you a message about who you need to go to talk to get training for that tool. If you encounter a problem with the tool, say you tried to use it and something was broken on it, this device incorporates a built-in system for being able to report those issues back. We have what are called resource managers at Make It Labs. They're basically people responsible for individual areas, like somebody's responsible for the wood shop, somebody's responsible for welding, so on and so forth. Each tool has a configurable list of potential problems. These are obviously just placeholders, but you can say, oh, this tool exploded twice when I tried to use it today. You say, okay, I want to report that issue, and then it requires you to badge in so that your name is attached to that issue report so that the resource manager could then follow up with you. Some of our tools, like our welders, get unplugged from the wall and either moved around or just unplugged and stuck under a bench for a while. We wanted this system to be able to detect that and report back to the back-end system that the tool has been powered off, just so we know what happened to it. So it's got a small lithium battery in it and a circuit which detects when power goes out, switches over, the software realizes, hey, power's out, goes through a sequence warning you of that. If the power comes back, in that meantime, let's say you just moved it for a couple minutes or for 10 seconds or something, it'll stay running. Otherwise, it goes through the shutdown sequence and powers itself off safely. And like I said, reports back so that our status board that we have up on the web will say, hey, this tool is offline. And that's it, just going through the shutdown sequence there. And it powers itself off. And here's a quick view under the hood, so to speak. We've got a custom board that we designed. Adam actually designed that and laid that out. Into that we've got a Raspberry Pi 0W. This is a quote-unquote $10 Raspberry Pi that has wireless on it, which is great. We've got a small lithium polymer battery pack. We've got the RFID reader that reads our RFID tags. We've got a little speaker in there that makes the beeps and boops. And that's basically it. It's fairly straightforward. It's going to be built into these boxes. This is kind of the halfway point for the mechanical work. You can see I've got the hole in the box here, but I haven't actually designed the plastic bezel that's going to go into it. It's an off-the-shelf box that we are just doing CNC machining on to modify it for our needs. The top half of the box, the lid, will be where the low voltage electronics, the logic board lives, and then the bottom half of the box will be where high voltage electronics lives. And the only example I've got of that right now is this little relay module. These connect with what are called Grove headers. This is kind of a standard thing in the hobbyist community these days. We've got up to 4 of those, so you can connect relays and sensors and other stuff. Also, we've got an expansion header that allows connecting off to another custom board that we're going to build that might integrate a bunch of the features we need to run common tools. And then finally at the bottom we have isolated I/O, opto-isolator inputs and OptoMOS outputs. And that will allow us to wire it directly into something like a 3D printer or a laser cutter without having to use a lot of external electronics. So that's basically it. That's RATT. Happy Pi Day.